In this video, we're going to look at factoring trinomials in the same form as our previous video, ax squared plus bx plus c. This time we will have a coefficient in front of our first term, so a will not be equal to 1. Here's our first example, 3x squared plus 7x plus 2. Because this trinomial has a coefficient in front of the x squared term, we have to do things slightly differently than we factored trinomials than when a was equal to 1. We're going to utilize this chart over here at the right to help us to solve this type of problem. Our first step is to multiply our a term and our c term together. So 3 times 2 equals 6. I'm going to put that up top. So what we're going to be doing in this chart is looking for two numbers that multiply to give me 6, that add together to give me b. In my problem, b equals 7. So let's consider some factors of 6. 2 times 3 equals 6. However, 2 plus 3 equals 5. Another factor of 6 is 1 times 6, which equals 6, and 1 plus 6 equals 7. It looks like this scenario here is the correct one that will match up with our problem. So what I'm going to do, since my factors of 1 and 6 worked for my example, I'm going to rewrite my problem. 3x squared and 2 will remain the same. However, instead of writing 7x, I'm going to rewrite this problem as 1x plus 6x. Because 1x plus 6x still gives me 7x. So, now that I've rewritten my problem, I now have a polynomial with 4 terms. We learned earlier in this unit that polynomials with 4 terms can be factored by grouping. So I'm going to group my first 2 and my last 2 terms together. And now I'm going to find the greatest common factor. So the greatest common factor in my first set of parentheses is x, and I'm left with a 3x plus 1. In my second group, my greatest common factor is a positive 2, and I'm left with a 3x plus 1. If you recall from our grouping lesson, 3x plus 1 and 3x plus 1 are the same, so we're going to rewrite those as our GCF, and I am left with an x plus 2 in my second set of parentheses. And so the answer to my problem of 3x squared plus 7x plus 2 is 3x plus 1 times x plus 2. Let's try another example. So now I have the problem 4x squared minus 12x plus 9. The first thing you should notice about your problem is that there are no common factors, so it cannot factor by GCF. The next thing you should notice is that it's a trinomial with a coefficient in the front. So we're going to set up a table just as we did on the last problem. So I'm going to multiply a times c together. Here's my a and here's my c. 9 times 4 equals 36. So I'm going to be listing some factors of 36, such as 1 times 36, 6 times 6, 9 times 4, and there are others, but we'll start with these 3. As I test these factors, I want to see if any of them will add up to my middle value. My middle value here is negative 12. So let's do some testing. 1 plus 36 equals 37. So this doesn't work. 6 plus 6 equals 12. We're trying to get negative 12, so we're actually really, really close. So let's not consider 9 times 4. Let's consider negative 6 times negative 6, which would still give me positive 36. However, if I add it together, I would get a negative 12. That means negative 6 and negative 6 will be the factors that I'm going to use in my problem. So I'm going to rewrite my first term and rewrite my last term. But instead of negative 12x, I'm going to write negative 6x minus 6x from my chart. So now I'll continue my problem by grouping together the first two and the last two numbers. The GCF of my first group is 2x, leaving me with a 2x minus 3. The GCF of my second group is negative 3, leaving me with 2x minus 3. And so my final answer through the factor by grouping method is 2x minus 3 times 2x minus 3. And if you remember from our perfect square video, our answer can also be written as 2x minus 3 squared. Here's two more examples for you to try by yourself. 6x squared minus 7x minus 5 and 6x squared plus 13x minus 5. You may pause the video now and try these two examples on your own.